All right, so I would like to review the shear moment diagram. Um, if you already know this, then you do not need to watch this video, but if you're interested, I would like to go over this lecture series in preparation for your shear moment diagram, whether it's a quiz or a final um, or a midterm. Let's go over some of the basics. So this is really interesting. You always want to look around yourself to see where you can apply what you learn. And so I was at my desk one day and I was like, oh my God, this is such a perfect example of a loading diagram. And so here, what you see on the left side is a pin support, and on the right side is a roller support. But theoretically, they're actually pin. Um, but that makes it indeterminate outside the scope, and you wouldn't be able to solve it within the realm of this class, but that's besides the point. So here you have, and what I've drawn is a distributed load, and you can see that the load is uniform throughout the support from left to right. And you can also see right here that, we say that it's theoretically pin. So what that means is that it's in different color now. Let's see. You could see that rotates, right? And so as it rotates, it creates that curvature right there, right? So that tells me that it's pinned. Now we know that if it was fixed right here, then it would have that straight, then curvature, and that straight segment would form a 90-degree, right? So, all right. And here's an example. What happens is that once I took all the paper off, I actually took the paper off just to kind of prove a point, that it would come back to what is relatively straight. I think what ended up happening is that I had too much paper on it, and it seems like this experienced plastic deformation, and it did not return back to its normal state. Fun stuff, huh? All right. So if you don't know already, this is already uploaded on the handout portion labeled Beam, Shear, and Bending Moment Diagram, an alternate approach, solve problems. So what you have here is kind of the summary of the loading, and let's kind of go over that. So when you are solving for a shear moment diagram, these are kind of the basic steps that if you follow, it really assists in solving your or help assist drawing your shear moment diagram. So first, solve for unknown external reactions. That's the first thing. The second thing would be to develop a shear diagram, and you really just ask yourself, what is the vertical force doing? And all you see is the vertical force. You don't see anything else. And you have your shear diagram will close on both ends, and you use the transformation chart below to kind of see what it looks like. So here, if you had a point load in your shear diagram, that would be a vertical travel either up or down. If you had a distributed load, then that would mean that you would be having a slope. And then if you had a triangular loading, depending on how you're loading, it would be parabolic with a skew. And finally, if you have a moment, it does not show up in your shear diagram. The best thing to do is have this printed out to your side. As you solve the problem, you can kind of refer back to this. There's a little comment section on the right side. And how do you develop your moment diagram? A, it's based on the area of the shear diagram. B is saying that positive shear is addition and negative shear is subtraction. Max moment and minimum moment is when shear is equal to 0. Moment closes at 0 at both ends, unless fixed to a wall.